can extract from IT data, which makes the Internet of Things so interesting. Data analytics algorithms vary significantly in capabilities and scope. So there are algorithms which find us the known knowns, then there are algorithms which are able to extract the known unknowns, and as of very, very recent, there are algorithms which are even able to extract the unknown unknowns from our data sets. An example of the first class of algorithms, the known knowns, is simple linear regression. So for example, assume we instrumented a shop in the high street with sensors which are able to measure the amount of goods on the shelves. If we now plotted that amount against time, linear regression would allow us to establish the best fit for how quickly the shelves are being emptied. An example of the second class of algorithms, the known unknowns, is machine learning. Now here, sophisticated algorithms are able to arrange data into clusters of prior specified characteristics. In addition, these algorithms are able to predict most likely events to occur. With our previous example, machine learning would be able to establish which products are being taken off, at what rate, and therefore enable better supply chain decisions. Now, the third class of algorithms, the unknown unknowns, is currently pushing the boundary of what is possible in artificial intelligence. These deep learning algorithms, some of which also rely on machine learning, are able to get insights from data which we humans even didn't imagine existed. Coming back to our example of a smart shop, deep learning analytics may reveal why certain products fly and others don't. So what's the aim of these analytics approaches? Why do we do this? Well, generally, we are after two ends of the insight spectrum, really. On the one hand, IoT and data analytics allow us to detect anomalies in real time, that is, trigger an alert of something going wrong or about to happen. For instance, using our example, if we detected that a specific product ran out, an alert could be sent to the shop owner to order more stock. That alert could even be sent to the supply chain without the shop owner even noticing. Now, on the other hand, collecting all the data and crunching it over time allows us to detect long-term trends, which in turn allows us to construct certain policies. For example, imagine we observe that a specific product does not sell in winter, but is really popular in the summer. The shelf stocking policy could then be adapted to these long-term patterns.